It is commonly assumed by physicists that the laws of physics and the constants of physics are inviolable. They are the same today as they were in the past. They'll always be the same. Different parts of the universe, exactly the same. That's the fundamental part of science. Do the laws of physics, do the constants of physics change?
I think I have to agree with my colleagues that, in fact, the laws of physics were set in the beginning of time at the initial singularity, and they will continue to exist unchanged throughout all reality. But we have to be careful about this word constant. For example, in cosmology, it in the 1950s was thought by many people, Fred Hoyle, who pushed the steady-state theory, for example, that the Hubble constant was a real constant and never changed with time.
The Hubble constant,
which measures the expansion
of the
rate of the universe. Right. And Hoyle made the postulate that this was invariably true, that this particular constant for rate of expansion was true for all of existence. That implied that the universe had to be expanding forever, because otherwise it would have had to start at a faster rate or a slower rate or whatever. We now know, since we've measured it, that the Hubble constant is actually changing. In other words, constant in quotes, because this particular constant is a constant only for our particular period of universal time. If the universe started in initial singularity, as the evidence suggests, and ends in a final singularity, as I think the laws of physics require, the Hubble constant will start at plus infinity, where it's expanding at infinite rate at the initial singularity, go to zero when it stops expanding, and then go down to minus infinity. Take on all possible values that a real number could, minus infinity to plus infinity.
What about all the specific constants that are important for the structure of the world? Gravitation, electromagnetism, gravity. Do these constants change over time?
I think that the laws of physics require them to change with time. They're not true constants. They're just like the Hubble constant. They measure, the particular value we measure today is a measure of what time we are now measuring these constants in universal history. The reason for thinking this is, think about the fine structure constant. We know, because we have measured it, that this particular, quote, constant depends on the energy at which we measure it. What is normally called the fine structure constant.
Which has to do with the electromagnetic radiation.
Yes, the strength of the electromagnetic force changes at the energy at which it is measured. What the fine structure constant is, quoted in the literature, is the fine structure constant at effectively zero energy, when you minimize the energies involved in the interaction. But think about quantum mechanics. Quantum mechanics says there's an intimate connection between time and energy, expressed sometimes in the energy-time uncertainty principle. So variations in energy are associated with, connected to, variations in time. So we might expect, if there is a variation in the fine structure constant with energy, which we know is true, there might also be a variation of the fine structure constant with time.
What are the implications if some of these constants of physics are in fact changing over time?
Well, for example, what you can imagine is that in the early universe, the fine structure constant, which has to be greater than or equal to zero, otherwise the whole theory collapses in inconsistencies and singularities and other terrible disasters. It starts at zero value, the lowest value it can possibly have. Then over time it increases to its present value today, 1 roughly over 137. But what the laws of physics will allow it to do is to steadily increase with time, becoming infinite near the final singularity. You have this number, which must be positive or zero, starting at zero, going to plus infinity. In other words, it's the same sort of thing with regard to the Hubble constant. This particular constant, its particular value is telling us what time we are actually living in universal history. So
each constant by its nature would be related to this period of time between the Big Bang, the initial singularity, and some future event which you think will be coming back to a final singularity,
Yes.
which other people think the universe will continue forever in its expansion. But either way, this fine structure constant, as with other constants, have a value that is not so much constant in time, but defines the moment in which you measure it.
Exactly. So the fundamental laws of physics, which couple these constants, in quotes, together, allow them to vary. The usual way of thinking about this, however, people ignore the effect of the cosmology these constants, these laws of physics are actually doing their thing in. You can't really fundamentally ignore that, because quantum mechanics fundamentally is a global theory applying to all of reality. When you take that into account, it's fairly clear that these constants depend on universal time. And we don't have to therefore worry about what this specific value is, just like the Hubble constant is now measured to be roughly the rate of expansion of the universe, 70 kilometers per second per megaparsec. It doesn't matter the specific numbers, because these are going to be changing with time. This specific number tells us we are now measuring it at now, this instant in universal time. The same for the fine structure constant.
Does this mean, though, that at this time, obviously, we have life, we have sentience, we have consciousness, human beings exist, with these fundamental constants all within a certain range? Does that mean that the time that we live in is something special?
It's special in the sense that it's engineered to give rise to our particular form of life. So here we are.
Who's the engineer, not you?
I'm certainly not the engineer. I would say that the engineer is the source of the laws of physics, which created the laws of physics, which created space, time, and matter, which are governed by these laws of physics. Physics tells us they all come out of the cosmological singularity. So I would say that the designer of this universe of space, time, matter is the cosmological singularity.